Kia ora Year 12. This question is also from the May-June 2021 Pure 3 paper. And no one's asked me for it yet, but I think you should all watch it because it's a really, really nice question. And it looks hard, but actually just uses some basic ideas from about Year 10 maths. The weird thing about it is that there seem to be like no numbers and no functions. So we're given a curve, and this is the curve here. So y equals whatever. And the normal to the curve at the point P with coordinates x, y, meets the x-axis at n. So we're going to be finding kind of a generic normal line. And the point M is the foot of the perpendicular from P to the x-axis. So the coordinates of point M we can get pretty easily. If this point P is x, y, then we know that M has coordinates x, 0. And what we don't know yet are the coordinates of point N. And the curve is such that for all values of x in this interval, the area of the triangle PMN is equal to tan x. So we're probably going to use half the base times the height in here. Okay, so it looks weird. Let's just get going. Show that MN over y is equal to dy by dx. So MN is this length here. Y is this length here. And if you draw it like that, I think you can already see the Year 10 gradient idea coming out. So we have to show that that is equal to dy by dx. So let's go slowly through that. Because it's a show that question, you really have to work quite logically. So we've got this at point P. So the gradient of the tangent is dy by dx. So the gradient of the normal is equal to -1 over that. So -1 over dy by dx. Right, now line PN is part of the normal line. Okay, so that means that the gradient is -1 over dy by dx. But what is that gradient? Well, that gradient is change in y, which is going down, over change in x, right? So we can write it out as the rise over the run, or better, change in y over change in x is equal to -y over mn. And we know that that gradient has to equal -1 over dy by dx. So we get y times dy by dx is equal to mn, which gives us what we need, which is that dy by dx is equal to mn over y. Okay, so far so good. So now we've got to show that x and y satisfy this differential equation. And this is where I'm going to use the fact that the area of that triangle is always equal to tan x. So area PMN is equal to tan x. So half times the base. Where's the base? Right, so the base is MN and the height is PM, but we know that that's y. So half times mn times y is equal to tan x. But we know from here that mn is equal to y times dy by dx. So we get a half y dy by dx times y is equal to tan x, which gives me the result we need. So 1/2 y squared dy by dx is equal to tan x. So that's that bit done. Okay, and I think that's the part of the question that is the most thought-provoking. And then what we've got to do from there is we just have to solve the dE to find the equation of the curve, giving y in terms of x. In other words, we can't just stop when we've subbed in this constant, but we're told that y equals 1 when x equals 0. So as usual, we're going to separate the variables. So we have a half y squared dy is equal to tan x dx. So integrating both sides, we can see that this tan x, we're going to want to do that by rewriting that as sine x over cos x, because at this stage of the year, we should be recognizing that here we've got the pattern of a function and a scalar multiple of its derivative. So that's going to integrate to give me a log. Right, here we've got 1/6 y cubed is equal to the natural log of cosine of x. Now, when I differentiate cos of x, I get negative sine of x, so I have to put a negative sign here. So it's that plus the natural log of c. So I could write that as just c, but it's going to be easier if I make it into a log form. And I know that 0, 1 is on the curve, so I can sub in now to find the value of log c. So we get 1/6 times 1 cubed is equal to negative log of cos of 0 plus the log of c. So 1/6 is equal to, this is 0 plus the log of c. So that means that I can go back to here and now write this in. So we get 1/6 y cubed is equal to negative log of cos x plus 1/6. Just checking that I haven't stuffed anything up. So now that looks good. I need to get an expression for y. So we're going to have y cubed is equal to 1 minus 6 log of cos x, giving me a final answer of y is equal to the cube root of this. So there you go. I think that's quite a nice DE question. Sometimes they can just get really, really repetitive and boring, and this one manages to do something a little bit different. So make sure that you've gone through that thoroughly, and just realize that, of course, if you get stuck on this first bit here, which is only 1 mark, so it can't be that complicated, you're probably getting stuck on it because you're overthinking it, but you can keep on going from here and still get 8 out of the 9 marks. Thanks for watching. Just keep on sending in any questions that you want video.